Hello, this is Matt from Matt Heaney Apps and welcome to part 4 in our 6-part full game tutorial series teaching you how to make the full iPhone game solo mission in Xcode using SpriteKit and Swift. So far we have a ship in space that can fire bullets at enemies, we can kill the enemies and the enemies can kill us. In this video we will take what we have so far and start to turn it more into a game. So today we will set up our score system, our level system and our lives system. So for our score system, the player will earn a point every time they kill an enemy. For the lives system, the player will lose a life every time an enemy moves past the player. And for the level system, when the player reaches a certain score, the game will level up and enemies will spawn more frequently, making the game more difficult. So by the end of this video, your game will look like this. So let's jump back into Xcode to continue. Okay, so back into Xcode and back into our game scene.swift. Now, as I said, today we are dealing with our score system, our level system and our lives system. For our score and lives system, we will have a label on the screen which shows the player's score and how many lives they have left. So before we can do anything, what we're going to do is set up a custom font in this Xcode project so we can use a custom font in this game which we will use in our labels, because custom fonts are really easy to set up and they make a massive difference. So first things first, we will find the custom font file, the .ttf, which is in the assets folder which you downloaded to get the images. This font is a free to use font which I downloaded from daffont.com, and for full credits about this font please check out the video description. And we'll just drag this into our project. We want to make sure copy items if needed is ticked, and we want to tick just here as well and hit finish. So the custom font, the bold font, is now in our project, but we can't use it just yet. We still have to set this up. To set this font up, what we would do is move into our home area of Xcode, this just here. We'll move into build phases and into copy bundle resources. Now here, all we have to do is make sure the bold font.ttf is on this list. If it's not, find the plus symbol and add it. If it is already on your list, then you haven't got to do anything here. But if it's not on this list, this will not work. So make sure it's here on this list. Then what we'll do is jump into our info.plist, and here we can set up the custom font so we can use it in our project. So what we will do is right click, go add row, and the extra row we want to add to our plist is fonts provided by application. If you use a capital F, it should find it for you. We're going to open this up, and here all we have to do is say the file name for the font. So this here, the bold font.ttf, no spaces, in camel case. Okay, so lowercase t, capital B, capital F. Exactly as this is here. So the bold font.ttf. And now just with that, we can now use this custom font in the project. So back into the game scene. Okay, so we can now do our score system. So for our score system, all we would do is declare a variable to keep track of our score, and then we will simply show this score in a label. So we will globally declare in the game scene a brand new variable, and we'll call this game score, and we'll start this off at 0. So game score will keep track of the score in the game. This is a variable, so var rather than let, because the value of game score will change. If we put let, we would not have been able to change the value of game score. We also want a label, and we are declaring this globally within the scene because we're going to set it up in a did move to view, but then affect it somewhere else. Therefore, we will do this globally. So we will say let, call this score label. It's going to equal an SK label node, so a label object, and it will use the font, the bold font, the name of the custom font. So we now have our variable and we have our label. So we will now set up our label. So into the did move to view, and we'll do it here because we want our label on the scene straight away. And here we will set up our label. So score label.text to take our label and set the text. And the starting text is going to say score:0. We will give this a font size of 70, a font color
of white, so skcolor.white color. We will give this a horizontal alignment mode of left. And what this means is the position that we give this label in a few seconds will be the left of the label, and that will always be the left of the label. So if our label text got longer, so for example, if we scored somehow 1,000, what would happen is the label would expand to the right across the screen rather than outwards from the middle, because that way some of the label might go off the screen. So by locking it to the left, we are avoiding this potential problem. So we will say score label dot horizontal alignment mode equals sk label horizontal alignment mode dot left. So now the left of the label will always stay in place and it will expand to the right. And we're doing this to the left because the position is going to be in the top left hand corner. So CG point, the X is going to be 15% of the way across the screen, because remember we lose some of the width of the scene on some devices, so we can't do it all the way to the left. So self.size.width times 0.15, and the Y will be 90% of the way up the screen. So self.size.height times 0.9. We'll give this a Z position. This will always be on top of everything. So we could give it a Z position of like 5, but to make 100% sure it's always at the very top, the Z position will be 100.
The Z position of the background and the ships and the bullets are nowhere near 100, so we can safely say this label will always be on top of everything.
And then we can just add it, like so. So we now have a score label. Its starting text will say score:0, font size of 70, font color of white. It's in the top left hand corner of the screen with alignment mode left, so it locks the left of the label in place. We gave it a very high Z position to make sure it's always on top of everything else in terms of layers, and then we actually made it. So we now have a score label. We now want to add to our score and display our actual score in this label. So what we're going to do is make a brand new function called add score. Now in here we will do everything that we have to do to add to our score, and then simply call this function when we want to add a score. So when we want to add a score, we will take game score, our new variable name. We will add 1 to this, and then all we have to do is show this in the label. So score label dot text. So we're taking our label and we're changing the text to say score, and now what we want to do is display game score. And to show a variable or a constant in a label, we will do a /, open bracket, game score, close bracket. Okay, so with this here, our label will show our actual score. Okay, so when we run add score, we're going to add 1 to our score
And then show game score in the label.
All we have to do now is tell this when to run. Now in solo mission, the only way that you can get points is by killing an enemy. So when a bullet hits an enemy, the player will get a point. So we will move into our did begin contact, and we're going to find where our bullet hits the enemy. And now here, all we have to do is say add score. So now if a bullet hits an enemy, add score is going to run. So we'll add 1 to our score and show this in our label. And just with that, our score system is now set up. So we're going to hit run and we will check this out. So now here is our game. And as you can see, when we hit an enemy with a bullet, our score goes up in our label, which is in the top left-hand corner of the screen. Okay, so back into Xcode, and we will now move on to our level system. In solo mission, the level system is going to be when you reach a certain score, the game will level up, and then the time gap between enemies spawning will get shorter, so you have more enemies spawning, so you have more enemies to kill. So for our level system, we will move into the function that we already have called start new level. Now, as you may remember, we are calling this straight away when the game begins, and at the moment it is saying run a sequence to spawn an enemy and then to wait a second and then run this forever. So spawn, wait for a second, spawn, wait for a second, spawn, wait for a second, and so on, so we get a nice flow of enemies. So here we will set up our level system, and then all we have to change is this wait for duration depending on which level we're currently on. The higher the level, the shorter the wait for duration, so the more often we get enemies. Now before we throw our level system in place here, there's one quick thing I want to do, and that is to find our sequence, and I want to swap these actions round. Because at the moment, as soon as the game begins, we get an enemy and then we wait for the second, but instead I want to wait for the second and then spawn an enemy, just so the player actually has a chance to start the game before their enemy comes down, okay? So that's just polishing off a little something. When we set the sequence up a few videos ago, I mentioned that I wasn't sure which way round these actions should go in this sequence. Doesn't really make a massive difference, just a tiny bit of polishing off. As I mentioned back then, it's up to you which way round you have this sequence, but I now personally think that this way round is better for gameplay. So for our level system, to start with, we need a global variable called level number, and this will keep track of which level we're on. We're going to start this off at 0, and then what we're going to do, we will call this function when we want to start a new level. So whenever we run this code, we want to add 1 to our level. Okay, so the very first time we call it, it will go from 0 to 1, starting us off at level 1. We will then run this code every time we want a new level to start, and then in which case the first thing we will do is move from level 1 to 2, 2 to 3, 3 to 4, and so on, depending on how many levels you want. Okay, so what we will do is, when we start a level, we want to completely stop these enemies spawning and then restart this sequence to spawn enemies with a smaller gap. So stop what it's currently doing and then rerun this, but with a different duration. So to do this, when we run our action, we are going to add a key, and here we're going to put spawning enemies. So now this action that's being run has a reference name. It has a key. And now what we can do is stop that action. So what we're going to do is say if self.action for key spawning enemies, so this down here, if that doesn't equal nil, then we can stop it. So self.remove action for key spawning enemies. Make sure these are the exact same as this down here, because otherwise it won't work. What we're saying is, when we run this, run it with a key, so like a reference name of spawning enemies. So now, when we start a brand new level, if this is already running, and therefore we're already spawning enemies, we want to stop it from spawning enemies. So if the scene has an action called spawning enemies, because spawning enemies doesn't equal nothing, then remove it. So now if we're spawning enemies, stop it, because we're going to rerun this in a slightly different way for the next level. So we can now set up our different durations depending on the level. So we will say var, and we will call this level duration, and this is going to be an NS time interval. So it's going to be a number that is going to be in seconds. Now in a moment, here we're going to set level duration a value, so a duration depending on what level this is going to be, and then we can update this down here, so the gap between enemies is then what we want it to be for that level. So we're now going to use a switch statement. It's a bit like a big if statement. So we're going to say switch for level number. We'll put this in and I'll explain what it's doing. So case 1, what we want to do is set level duration to be the gap in time between enemies spawning that we want for this level. So for level 1. So level 1 is going to be, I'm going to put this at 1.2 seconds. So we're saying take level number, and if level number is set to 1, then set level duration to this. If we're on level 2, set level duration, so that gap between enemies, to be 1 second. Level 3, 0.8 seconds. Level 4, 0.5 seconds. Now I only have 4 levels in my game. If you want to add to this, then add them here. For the default, so if level number is not 1, 2, 3, or 4, then something has gone wrong. So what we're going to do, we will set level duration to 0.5 anyway, as a bit of a safety backup. And we're also going to print a message to ourselves saying, cannot find level info. Okay, so if this isn't any of our levels, then do this. So now, if we're level 1, level duration is set to 1.2, so 1.2 seconds. Level 2, level duration is set to 1, so 1 second. Level 3, level duration is 0.8 seconds. Level 4, level duration is 0.5 seconds. Now what we can do when we spawn our enemies is, instead of saying spawn every second, spawn every level duration value. So if we're on level 1, here we're going to have 1.2, so the wait for duration is 1.2 seconds. If we're on level 2, here we're going to have 1 second. Level 3, 0.8 seconds, so we get a new enemy every 0.8 seconds. And then level 4, 0.5, so we get a new enemy every half a second. So that's all the info around our new levels. All we have to do now is tell this when to run. So we want to trigger this code to start a brand new level if we have reached a certain score. So we're going to move to our function to add a score. And here we're going to say if we reach a certain score, then run the code to start a new level. I only have 4 levels, so I'm only going to have 3 trigger points. So when you move to level 2, when you move to level 3, and when you move to level 4. So after we've added a point, we're going to say if game score equals, and my trigger points will be 10. So if it equals 10, do the following, or game score equals 25, or game score equals 50, then run start new level. So if our score reaches 10, go from level 1 to level 2. If our score reaches 25, go from level 2 to level 3. And if our score reaches 50, go from level 3 to level 4. Now, if you have more levels, all you have to do is keep adding to values for here, okay? And just with that, our level system is now set up. Once we've reached a certain score, we will run start new level, where we are adding to which level we're currently on. We are stopping enemies from spawning if they're already running, because remember, the first time this runs, they will not be running because the game hasn't started yet. We have set how long of a gap there's going to be between enemies spawning, and then we ran our sequence to spawn enemies with the time gap that we set depending on which level we are on. So we now have a level system set up and ready to use. So now when you're playing the game, as you get a higher score, more enemies will be spawning, and therefore you have more enemies to kill, therefore the game becomes harder. What we're now going to do is set up our lives system. Okay, so in solo mission, you start with 3 lives, and you lose a life every time you let an enemy ship pass you and leave the bottom of the screen. So that is why more enemies spawning makes the game harder, because you have to kill all these enemies. If you let 3 past, it's game over. So for our live system, just like our score system, we need a global variable called lives number, which is going to equal 3, the starting number of lives. We also want a lives label to show our lives on the screen. So SK label node, font named, again using the custom font, the bold font. Okay, so we now have a variable to keep track of our lives, and we have a label to show how many lives the gamer has left. So every time we lose a life, we're going to take 1 away from this and then show that number in our label. So let's begin by making our label. Into the did move to view, we will give it some starting text that will say lives 3. We'll give it a font size of 70, font color of white, so skcolor.white color. And just like with our score label, which is on the left hand side of the screen, we set the alignment to left. As this label's on the right, we're going to set this alignment to the right. This label will not be getting bigger, so the label won't be expanding, but it just makes it easier to position it in place. So lives label dot horizontal alignment mode equals sk label horizontal alignment mode dot right, and we will give this a position, so CG point. And as our score label is 15% of the way across the screen, our lives label will be 15% of the way in the screen from the right, so 85% of the way across. So self.size.width times 0.85, and the y self.size.height times 0.9, again to match our score label. Z position of 100 to guarantee this is always at the top, because we're never going to have a Z position higher than 100. And then we can add it. Self.addChild lives label. So we now have a label in place to show our lives. What we now do is set up a function to take a life away, and then simply call it and run that code when we want to take a life away. So we're going to say func lose a life, And now in here, we are going to take 1 away from lives number and update our label text to show our new number of lives. So take 1 away and update our label text to say lives and then show how many lives we have left. What we also want to do is make this label kind of bounce so you can tell that you have lost a life if a ship goes past you. So we're going to make it get bigger and get smaller just really quick, just so it kind of catches your eye so you can see that you have lost a life. So we want an action called scale up, an sk action.scale to 1.5, so get 50% bigger over 0.2 seconds, and then scale back down to 1 over 0.2 seconds. Set these up as a sequence. So skaction.sequence in the square brackets because it's a list or an array. We want to scale up and then scale down and then run this on our label. So it's run action scale sequence. So now when we run this code to lose a life, we're going to take 1 off of our lives number. We're going to update our label text, and then to make it really obvious that we've lost a life, we are going to run a sequence of actions on our label, so our label will get a little bit bigger and then go back down to normal size, just so, like I said, it's really obvious that you've lost a life. So that for now is all of the code we need to lose a life. All we have to do now is run this when we want to lose a life. So in solo mission, we are going to lose a life if an enemy ship leaves the bottom of the screen before we can hit it with a bullet. So if an enemy ship moves past the player off the screen and therefore we've let it past, we are going to lose a life. Now the vast majority of this code is already in place, so this is actually really quick and really easy to do. What we're going to do is move into our spawn enemy, and here we have the code to spawn an enemy and to move it off the bottom of the screen. So this sequence here, to move the enemy and then delete the enemy, is going to keep running until either it's finished or we've hit that enemy with a bullet and removed the enemy from the game. So all we have to do here is add an extra action to our sequence to say if the enemy does complete moving to the bottom of the screen, not only delete it but also lose a life. Because if it finishes moving, that means it would have left the bottom of the screen and would have passed by the gamer without being hit by a bullet. So all we have to do is add an extra action called something like lose a life action. So we an sk action.run block and then the name of the function. So lose a life. So this from up here. So now that action will run this code here. And then all we have to do is say for the enemy, if it leaves the screen and it has been deleted, run lose a life action. So now the enemy is going to move down the screen, and if it reaches its destination at the bottom of the screen without being hit by a bullet, because remember, if it's hit by a bullet, it is then deleted from the game and all of this will stop for that enemy. So if it reaches its destination, delete the enemy and then lose a life. So that for now is our life system set up. In the next video, we're going to deal with game over, so if we run out of lives. But for now, if an enemy leaves the bottom of the screen, we will lose a life. So we now have a score system in place, we have a level system in place, and we have a life system in place. So hit run and check it out. So now here is our game. If we hit an enemy with a bullet, it's going to add a point, and if an enemy leaves the screen, we'll lose a life, and our lives label bounces every time we lose a life to make it really obvious that we have lost a life. Now at the moment, our lives is going underneath 0, and that's because we haven't got a game over yet. But we'll be dealing with game over in the next video.
So Solo Mission now has a score system, a live system, and a level system. In the next video, we will deal with game over and restarting the game once it is finished. But for today, that is all. As always, thank you for watching. If you liked watching this video, which I really hope you did, hit that like button, hit subscribe, leave any feedback down in the comments, and I will see you next time. Goodbye.